This video covers section 2.3 in the book, which is all about lines. So the first thing to discuss with regard to lines is the slope of a line. There's a few different ways we can define the slope. One way that may be familiar to you is the rise over run, and this just means the change in y over the change in the x value, and we can find this by subtracting or finding the difference between the y values, between the y values and the x values. So y2 minus y1 over x2 minus x1. And we denote the slope with the letter m. So we'll see m, and that will signify that we're talking about the slope. Now there are two equations that we're going to use to write the equation of a line. The first is the slope-intercept form of a line, and that looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. The second equation that we'll see is called the point-slope form. That is y minus y sub 1 equals m x minus x sub 1. So we still have m, and that's the slope, and then x1, y1 is a point that the line goes through, so I'll call that a pass-through point. Now when we're trying to decide which equation to use, we really just determine what is given to us. If we have the slope and the y-intercept, we're going to use the y-intercept form of the equation. If we're given a pass-through point as well as the slope, then we use the point-slope form of the equation. So in this example it says find the equation of the line that passes through the points -2, 1 and 3, 7. Also graph the equation. So what we need to first determine is which form of the equation we're going to use, and here we have 2 points. Now backing up, we don't have the slope yet or the y-intercept. We have 1 point, so we're good here, but again we don't have the slope. So in either case we're going to have to first find the slope. So remember, the equation for the slope is x2 or y2 minus y1 divided by x2 minus x1. So what we'll have here is 7 minus 1 over 3 minus -2, and we end up with 6 over 5. So that will be our slope. So we have the slope, and now we can use either of these points. I'll just use this first one and then plug everything into this point-slope form of the equation, and we can come up with our equation of the line. So plugging in the slope, 6/5, and the point -2, 1, we have this, y minus 1 equals 6/5 times x minus -2. Simplifying things, we end up with this, and then y minus 1, distribute the 6/5, so 6/5 x plus 6/5 times 2 over 1, we get 12 over 5, and then the last step is to add 1 to both sides, and we get y equals 6/5 x plus, well, 1 is the same as 5 over 5, so getting a common denominator, we're able to add, and there we have an equation of the line. So there are there's a few different ways that we can express this final step. This is one of them, and this is totally appropriate. So we know that the slope is 6/5, and the y-intercept is 0, 17 over 5. To graph this, we start at the y-intercept. The y-intercept is 17 over 5, which is the same thing as 3 2/5. So somewhere right here will be the y-intercept, and then what we're going to do is we're going to count off the slope. Now 6/5, that tells us we're going to go up 6 units and right 5 units, up 6, right 5 units. So from the y-intercept we're going to go up 6, right 5, and counting that off we're going to end up somewhere like right here, and then we just connect those points with a smooth line. Let's try that again. Okay, so there is the solution to that question. Let's look at another example. This question says to simply graph this equation. So the easiest way oftentimes to graph an equation is just to put this into y-intercept or slope-intercept form. So we want to write this in y equals mx plus b. So 3x minus 4y plus 12 equals 0. And let's solve for y. And doing so we get y equals 3/4 x plus 3. So what that means is the slope here is 3/4. The y-intercept, which is b, is equal to 3. So to graph this, plot the y-intercept at 3 and then go up 3, right 4, and then we can connect these points with a smooth line. So there we have the equation of the line, or I'm sorry, the graph of that line. The second way we can graph this line is to use the intercept method. So what we do is we find the x-intercept, and to do that we set y equal to 0 and figure out what x gets us. So what we do is we say 3x minus 4 times 0 plus 12 equals 0. So we get 3x equals negative 12. X is going to equal negative 4. So that'll be the x-intercept. And then we do the same thing to find the y-intercept. Set x equal to 0. We get 3 times 0 minus 4y plus 12 equals 0. That goes away. Negative 4y equals negative 12. Y equals 3. So there is the y-intercept. So once we have the x-intercept and the y-intercept, we can very easily plot both of those points and then connect those. And what we see is that this right here is the y-intercept, which we already found as 3. Then the x-intercept is just going to be negative 4, and that's confirmed with the line that we already drew. Moving on to a discussion of parallel and perpendicular lines. Well, parallel lines, are two lines with the same slope. And perpendicular lines are two lines whose slopes are opposite reciprocals of one another. And just what that means, let's suppose we have the slope of one line that is 3/4. The perpendicular slope is going to be the reciprocal, so 4/3, but it's going to have the opposite sign. So if we have two lines whose slopes are 3/4 and negative 4/3, that means those lines are perpendicular. So to answer a question like this, which is saying, are these lines parallel, perpendicular, or neither, what we need to do is find the slope of each, and then we can make a comparison between the slopes. So to do that, let's write both of these lines in slope-intercept form. So writing both of these in slope-intercept form, we get the first line having a slope of 3, we have the second line having a slope of negative 1/3, and these are actually opposite reciprocals of each other. So we have 3/1 and negative 1/3, so that tells us that these lines are perpendicular. All right, a couple more examples here. Write the equation of the line that is parallel to 5x minus 6y equals 3 that passes through the point 12, 1. So because these we want to come up with a parallel line, we need to first determine what the slope is of this given line, and then the new line that is parallel to this given line will have the exact same slope. So let's write this equation in slope-intercept form and find the slope first. Solving for y and doing some simplification, we get y equals 5/6 x minus 1/2, so that tells us the slope is 5/6, and the y-intercept is negative 1/2. So we're going to use this given slope to come up with a new line that passes through the point 12, 1. We use this same slope because the lines are parallel, and because the lines are parallel, we want the same slope. So we'll use this point slope form because we have a point and we have the slope. So y minus 1, which is the y-coordinate, equals 5/6 x minus 12, which is the x-coordinate. And then we're just going to simplify and doing so we end up with the line y equals 5/6x minus 9. So the only difference between this line and the given line, they have the same slopes, 5/6, but they pass through the y-intercept at a different spot. And then on this last example, I think it's going to be helpful to look at the graph here. So it says, write the equation of the line that is perpendicular to y equals -8 that passes through the origin. Well, the line y equals -8 is going to go through the y-axis at -8. So there's the line y equals -8. Now we want a line that is perpendicular, so it's going to have it's going to cross this original line at a 90-degree angle, and it passes through the origin. Well, the origin is the point 0, 0 here. So actually, this new line is going to be right along the y-axis, and it makes a right angle with that original line y equals -8. So what's the equation of this line? Well, the equation of this line is just x equals 0. So that would be the solution here, x equals 0.